All right, guys, welcome back. Sorry I can't be there today. I have been down for the count since New Year's Day, but I wanted to make sure that we get rocking and rolling with some of our learning here this week. So today when we talk about this chapter, what we're going to be talking about is dilations. So it says, I can dilate a figure. A dilation, okay, is essentially taking a picture. I think about the cell phone, right? I can zoom in and out of something on my phone and it's still a dilation, right? It's still the same image. I'm just zooming in or out, making it bigger or smaller. So when we start talking about some of these things in this chapter, I'm going to relate it a lot to cell phones and pictures and zooming in and out. So it says transformation. A transformation is a change made to the location or size of a figure. An image is the new figure formed by a transformation. So prime notation is used to identify the image of a point. So we would read A apostrophe as A prime. Dilation is what we're talking about today. Dilation is a transformation in which a figure stretches or shrinks with respect to a fixed point called the center of dilation. A scale factor is the ratio of a side length in the image to the corresponding side length of the original figure. So it says here, original A is 2, 2. So let's go ahead and graph that. Now remember, this first number is your X, the second number is your Y. So when I think about ordered pairs, that first number is always going left or right from the origin, 0, 0. That second number is going up or down. So when I look at this, point A is at 2, 2. So that's A. I'm going to put a nice little A underneath there. Point B is at 4, 2. So I'm going to go ahead and connect those. Well, now it says image A prime and B prime. So I'm going to go ahead and change my colors for you. We're essentially zooming in or out or making this bigger or smaller. So A prime is at 4, 4. 1, 2, 3, 4. And B prime is at 8, 4. So here's my A prime. Notice how I'm showing this, and B prime. I'm going to connect my dots. So if I look at the pink to the green, I see the green is getting bigger, right? It's stretching. So in diagram A prime, B prime, the image of AB after dilation. So it says here that A prime, B prime, right, over AB is 2. So the scale factor is 2. So you might be saying, well, Mr. Dursky, how did I get that? Well, if I have A prime, B prime, I see that that is going to be a length of 1, 2, 3, 4 over AB is 1, 2. I know 4 divided by 2 is 2, so our scale factor is 2. Basically, that's saying that from the pink to the green, I made my line 2 times bigger. Okay, so when we talk about coordinate notation, when we say XY, we're going to start talking about KX and KY, where K is going to be that scale factor, or this 2. So down below it says using a scale factor greater than 1. It says draw quadrilateral ABCD with the following vertices. So let's go ahead and undo that. So I've got A, which is at -1, 2. It's really important that you stay organized and label these points. So there's A. B is at 3, 1. C is at 2, -1. And D is at -1, -1. So I'm going to go ahead and graph that. So we've got 2, -1. I've got -1, -1, -1, 2, and then 3, 1. Good. So when I graph that and connect my points, it looks something like this. Well, now they want me to find the coordinates of the vertices of the image after a dilation, after having a scale factor of 3. So I'm going to take these points and multiply it by 3. So if I look at A, and I'm multiplying this guy by 3, both parts, A prime is going to be -3, 6, because I'm multiplying both of my X and Y by 3. So when I graph that, I get -3, 6. So there's A prime. B prime, when I multiply those by 3, 3 times 3 is 9, 1 times 3 is 3. So I'm going to go in and graph 9, 3. 1, 2, 3. This is B prime. C prime, when I multiply that by 3, I would get 6, negative 3. This is C prime. And then D prime is negative 3, negative 3. I multiplied both those by 3. I'm going to go ahead and connect my points. So really, from the orange guy or my original quadrilateral to the blue guy, I'm just making it bigger by a scale factor of 3. So A prime was negative 3, 6. I don't know why that cut off. So my quadrilateral looks something like this. Okay. Now it's saying, well, hey, use a scale factor of less than 1. So example 2 says, draw triangle PQR with the following vertices. So P is at 4, 4. So we got 4, 4. That's P. Q is at 8, 0. And then R is at 6, negative 2. So if I graph this, they're saying, hey, make a triangle with the same proportions, right? The same dilation, but make it smaller. For me, I see all these numbers are even, so I'm going to multiply them by 1/2 or divide them by 2. So if I divide 4 and 4 by 2, I'll get 2, 2 for P prime. So I'll change my colors here. So we get 2, 2 for P prime. For 8, 0, I'll get 4, 0. So I'm dividing both of those by 2. So that's Q prime. R, if I divide that by 2, I'll get, R prime, I'll get 3, negative 1. So here is my triangle. All right, so I've got my original guy in blue and then my dilation in orange. So it says here, given AB with endpoints A at 0.5, so I'm going to go ahead and graph that, 1, B at 1.51, let AB with endpoints 3, 6, and 9, 6 be the image of AB after dilation. Find the scale factor. So I'm going to go ahead and graph some of these points. For me, I'm going to go to these prime guys because I see that they don't have any decimals or fractions. So 3, 6 is right here. Basically, they want me to find the scale factor. So here's A prime. B prime is at 9, 6. And we'll continue working on this here this week. This is B prime. All right, so it looks like this is making a line segment, which I can see right here with the way they made this. Now they want me to go and graph 0.5, so it's about right here, 1, which is right here, and then 1.5, 1, which is right here. So here's my original A, B, right? So from this original, right, we know this is the original because it doesn't have that apostrophe indicating the prime. Is my original to the new one getting bigger or smaller? Well, it's getting bigger. So I need to try and figure out, okay, well, if I have, let's look at just 0.8 here. How would I get from 0.5 to 3? Or how would I get from 1 to 6? So I see I would multiply this guy by 6. Let's see if that works here. Is 1 times 6, 6? Yeah. What's 1.5 times 6? Well, 9. So I know my scale factor must be 6. All right. So game plan today, I'm going to have you make sure these notes are done. Go ahead and check out the homework calendar. You need to do lesson 1, and there's also an IXL. We'll continue working on scale factors and dilations this week. Just wanted to make sure you guys had something to work on today. Welcome back. Looking forward to seeing all of you soon.